So please join me in welcoming one of the highlights of every Connect, and that's George Gray and his keynote. George.
One, two, three. Thanks, Joe. Not sure about you putting the Dave Piggott puzzle in at the beginning. I think you should have done it at the end, because I can see already some people starting to try and get a head start. Welcome again to Connect. This is the 24th. It goes up by one every time, and I'm always astonished by how many times we've done this. This has been 8 years. It's been an amazing 8 years for all of us, and I'm very pleased to be here today. So, a couple of quick slides. If you don't know what we do, you probably shouldn't be here. This is where the ARM ecosystem collaborates on open source software. And we have now over 300 engineers working on Linaro projects under the direction of our members from companies all over the world. And a lot of those projects cover most of the open source spectrum, from IoT devices to tools to edge to networking and server, and now a lot of activity over the last 6 months you're going to hear about this week over in terms of HPC. So Linaro is involved in a huge number of open source projects. And as a result, I'm very proud to say that Linaro has joined the GPL cooperation commitment. I'm not sure how many of you know about this. If you don't, you should. And so I'm going to ask Jeff Kaufman, Open Source IP Counsel from Red Hat, to come and tell you a little bit about it. Jeff.
George, thanks for inviting me here to speak. I am very excited to be here at Linaro Connect here in Vancouver. Let's talk about open source. I started my career as an embedded systems programmer back in 1991, programming little 8-bit microcontrollers. And coincidentally, that's the same year that the GPL version 2 was born. And frankly, back then, I did not know how to spell GPL. And sadly, I wasn't aware of what open source was or anything about the collaborative software development. And proprietary in my world was the dominant development model. And looking back, I realized how unfortunate this was and how things would have been better for me. And it has just been so exciting to see the dramatic evolution from proprietary to community-based development using open source licensing. And for the last many decades has been the driver for a significant amount of the innovative products and solutions developed today, including solutions developed by all of you. The benefits of open source are understood by all of us, the Linaro community, and us at Red Hat. So open source software works in part due to licensing structures that reduce friction for use and distribution. But there are also social norms that must be followed to ensure its continued success. So what do I mean by this? By way of background, the GPL, or the General Public License, is a very popular and important license. And it's one of the key attributes of the GPL is its copyleft provisions, which ensure that software remains free to run, copy, distribute, study, change, and improve. And as a matter of fact, the Linux kernel is licensed under version 2 of the GPL. And although the GPL has these great attributes, it also comes with terms that must be followed, and these terms can be a bit confusing, especially for those new using the license. And the harsh reality is that when you do not comply with the terms of the GPL, version 2, the license automatically terminates and you may become a copyright infringer and potentially liable for damages. Not a happy place. And this is an incentive to follow the rules of the GPL, and you should be following the rules of the GPL to ensure those freedoms. Sadly, there are some socially insensitive and opportunistic individuals and companies that take advantage of this termination clause and use it to profit from other people's innocent mistakes. And this hurts the open source communities. So let's be fair, people make mistakes. And sometimes people simply innocently misunderstand some of the requirements of the GPL. They should be given an opportunity to correct those mistakes before their GPL license terminates. So realizing this, the now current version of the GPL version 3 has a cure provision, and it allows people a certain amount of time to correct or cure their mistakes before the GPL license terminates, which seems fair. So this is why Linaro, Red Hat, and over 20 other companies, leading companies, and nearly 200 individual developers have adopted the GPL cooperation commitment for their GPL license code, or version 2 licensed software. The GPL cooperation commitment allows people a time to correct their mistakes for improper use of that GPL version 2 code, exactly what is already allowed under version 3 of the GPL. This is important because there are a significant amount of open source software and projects that continue to be licensed under version 2 of the GPL. So now I invite all of you to sign up to this initiative. Simply go to this URL and sign up. Take a picture, share it with your friends, light up Twitter, the hashtag GPLCC. And even if you don't own any GPL version 2 code, you can still sign up to show your support and further instill these social norms for dealing with innocent mistakes and provide greater predictability in open source licensing for all of us. I invite you to contact me at the email address here if you have any questions. Thank you for your time today.
Thanks, Jeff. Okay, good news. So I am going to talk a little bit about 2018. It's been an interesting year so far, and I'm sure we haven't finished it yet. I'm going to talk a little bit about ARM on ARM and activity on machine intelligence. The last 6 months seems to have gone very quickly from advanced intelligence being a little bit of an advanced technology to being here today. And I'm going to talk about automotive, the growth of the 96 boards ecosystem, and then a little bit about IoT and edge. So sometimes it feels like the world is on fire. It's been a very interesting year, I think, for everybody. I like to think that progress is always up and to the right, but it's not. It's not linear, like many other things in life. Sometimes we move forward 2 steps, and sometimes we take 1 back. And it seems like, in a lot of ways, we've taken 1 back globally over the last year. So we have tariffs, we have sanctions, we have protectionism. I'm hopeful that these things will pass. I don't think the world is a better place when we restrict trade, when we are protectionistic, when we retreat into our own countries. But even if it does pass as a result directly of what's been happening over the last few years, businesses and governments are having to review their global supply chains and their interdependence. And this affects all of us in this room. China, in particular, under the direction of its government, for very good reasons, is building out its own IT infrastructure using locally developed IP, everything from SoCs to the cloud. And this is a huge and ambitious project. It's one that hopefully will benefit the world. And we shouldn't abhor it, we should embrace it. Because there are 2 particular partners who China are working with to make this happen, and a whole bunch of other open source projects and technology are being used for this effort. And ARM, in terms of being able to license IP that can then be built upon by companies anywhere in the world, and Linaro, who is working on open source software globally, are two very important partners for anybody who wants to build their own IT ecosystem around computing and using collaborative development. So why? Why open source? Why not just go and create everything completely proprietary? And there are many reasons, right? The markets are global. If I am building a product, I want to sell it to every citizen on the planet. Open source is visible to everybody. There are no secrets. There are no boundaries. It's very difficult to restrict the flow of open source. And no country or corporation owns the work. It is distributed. It's available to everybody. And everybody can contribute to it and improve it. Now, of course, open source is an enabler. Commercial IP could and should be developed on top of open source platforms. If you want to build a special kind of proprietary security for your own application or for your own country, you should be able to do that. But you should be able to do it on top of an existing open platform that everybody can see. Because if you don't do that, then nobody will buy your product. Nobody will use your product because they don't know what's inside. So I actually think that open source is one of the bright lights of what is happening in the world today in terms of technology and technology development. And so the work that we are all doing is, I think, incredibly important. So let's talk a little bit about ARM on ARM. And this is the story about why are we not building all of our software on ARM processors? And you all know why. It's easier and faster to build it on the cloud in big servers. But things are changing. And what we want to be able to do is have everybody have a choice. If you want to build software on ARM, you should be able to. So how are we doing? We talked about this 6 months ago and a year ago. And this is about building any software you want on ARM. Not just software for ARM, not just native, but if you want to build software for another processor, for an Intel processor, or for anything else, you should be able to do that. So how are we doing? Well, it's getting easier. That's the good news. We have a range of development boards we've always had. Not much fun compiling kernels on Raspberry Pis, but you can do it. And then things like Dragon Board and the High Key and some of the activities in 96 boards have made a big difference. We're also seeing ARM Chromebooks. We have the HP NVX2, which is the Windows 10 ARM product that uses a Qualcomm chip and can also run Linux. Linux on Windows. So you can take a look at one or two of those. People are carrying them around and using them. You've seen the Synquesa developer box. We showed that last time. And I'm very pleased to say that Marvell have bought a system here that's outside. You can see that. Talk a little bit more about it at the moment. And we're also going to talk a little bit about the developer cloud. So you can build ARM software or any other software on a whole variety of ARM hardware. In particular, the Thunder X2 is the new chip from Marvell. It's SBSA and SBBR compliant. John Masters would say it's very boring, and he'd say that's a very good thing. This is a powerful machine. It has a server class SoC in it. It has up to 1 terabyte of RAM, and you can use it as a powerful workstation. So you can see one outside whole week, get your hands on it, and play with it, and you can also buy them from Marvell's partners who are actually manufacturing them. So how's the software doing? We also provide access to ARM servers in the cloud. And so I'm going to ask Martin Stadler, who's the Senior Director of the Linaro Data Center and Cloud Group, used to be LEG, now LDCG, and some of his team to come up and update you on what's been going on the developer cloud. Martin.
Thank you, George. All right, if you've been to a Connect before, you've heard us talk about the developer cloud. We have some significant updates we thought would be good for us to just briefly talk about. So I have Kyle and Jorge. Jorge is the developer cloud tech lead. Kyle is one of the technologists, and they're responsible for the work that we're going to do around the developer cloud, which we'll demonstrate. But let me tell you a couple key highlights. First of all, anybody can put an OpenStack cloud together on any sort of processor. And what I'm glad to really report is that we now have the work that we've been doing inside of Linaro, inside of the OpenStack Foundation, as part of that, passing 100% interoperability certification. This is a key achievement. It's the only one that we're aware of that's on ARM. It also means that we're now able to be interoperable with other OpenStack clouds that could be x86 or PowerPC, whatever it is. We are working with the OpenStack Foundation to try and figure out how we can actually be certified, because this is also the first time that the open source effort actually is the one that's certified instead of a company product. So that's number one. The next thing, as many of you know, and we've had a lot of people sign up for the developer cloud, there's been a lot of demand for it, and this is a really good story around ARM on ARM. The mission really has been to be able to provide that to the community and partners and the members. And we've got data centers still in Shanghai, in London, and in Austin, Texas. But what we are doing now is taking it out of beta and we're putting it into production. So what does that mean? It means that you have full support, you have the reliability. But it also means that what we used to give away for free will now entail a small fee. That is to keep the lights on in the data centers and to keep enough of resources to be able to watch and manage them. So, instead of me sitting here and talking, what I'd like to do is hand it over to Jorge and Kyle.
Thanks, Martin. So we have been working to make this process simpler for the users, so in a way that you can sign up pretty easily and then buy a project. So Kyle is going to show us the process of signing up.
So this is the new Developer Cloud website. You can sign up, log in from the home page. Once you've signed up, you'll receive a activation email. Click it, confirm your account, and then complete your registration. So we'll log in with a account that we have already set up. So once you've logged in, you can choose your preferred zone and flavor. We've got 3 zones to choose from: China, UK, and USA. We've got 4 flavors also: nano, small, medium, and large. So yeah, you can go to the website, choose your flavor, and then once you've purchased, you can head over to My Account and then to the dashboard, view your subscriptions, and from here you can access the OpenStack project and manage your instance.
Yeah. So after you complete the purchase, you are going to jump into the OpenStack dashboard. We have 3 different for each region that we have. In this case, we are jumping into the UK zone. So this is a pretty standard OpenStack dashboard installation running Horizon. So here you can see an overview of the resources that you have. So for this particular project, we have 24 vCPUs and close to 30 gigs of RAM. So the process of spinning up instances on an OpenStack cloud, so you have to click under Compute, then you go to Instances. You click on Launch Instance. You gotta pick a name, so I'm gonna say Demo. So the amount of instances that you wanna run, so I will say 3. So we have plenty choices for images. I will use the Bionic Ubuntu LTS, which is the latest one. So you can pick a flavor. Of course, the flavor has to be under the boundaries of the resources that you have available for this project. So I will pick Nano, and then I will click on Launch Instance. So this will go through the process of scheduling, building, and running the VMs on each hypervisor. So it's going to schedule, then build. This might take a few minutes. So after this is done, you can click on Associate a floating IP, and this will give you an internet IPv4, so you can access the instance from the internet. So of course, you can deploy some more complicated things or some more complex software stacks, such as a Kubernetes cluster. You can use almost any of the deployment tools that we have right now, such as UU, Ansible, or Terraform. So in this case, I've used UU for deploying this 6 nodes Kubernetes cluster. It has 6 machines, and each of those are using a Nano flavor, which just 1 vCPU and 4 gigs of RAM. So all of this, of course, running on top of ARM64. So you can, of course, also jump into the Kubernetes dashboard and see the nodes. So each node, we have 2 of them, and they are running containers running on top of ARM64. So I think it makes a good demo of what we can do on top of the developer cloud. And we would like to invite you to test the service. And we are open to questions. And Martin?
All right, great. Thank you very much for the demo. We are thinking about doing a Q&A session on Wednesday, maybe around 10:30, but TBD, if we get that done, you'll see it in Pathable. All right? Thank you.
Thanks very much, Martin. So actually, if you think about what you've just seen, so firstly, we're not going to become Amazon. We're not going into the data center business. What we're really trying to do here at Linaro is give the ecosystem early access to the latest hardware from our members. We couldn't do this without the members of LDCG. They're all donating hardware and their latest hardware, so you can actually really start to see that you can do all of this just as easily on ARM as any other architecture. And the difference is that we are not providing long-term commercial support for this. That's up to the other vendors. There are vendors in the market who are, like Packet, but this is a complete implementation running on a range of different latest hardware, and you have the complete open source implementation available to you. You can build this yourself from scratch, absolutely as we have created it. So we hope you'll use it. We will, with our members, scale it up according to use, but we're hoping over time that the big commercial providers will start to actually give everybody a choice of ARM servers in what they're doing. And this, I think, is a major step towards that. So well done to the entire team and also to the members who are supporting this. Right. So that's the hardware. We've now got a choice of hardware from laptops to workstations to the cloud. But how are we doing on software? How are we doing in terms of building natively on ARM? How are the development tools coming? Well, you can build Tiano Core, UEFI, U-Boot, EBBR compliant software as that specification completes. That is all being developed natively on ARM today. And many of the major commercial and open distributions, you can also build ARM natively on ARM. So Debian, Fedora, OpenSUSE, OpenMandriver, and others. There's still more to do, though, particularly in the embedded and IoT space. People who build embedded products, believe it or not, still use very, very old versions of Windows. I've been in a major corporation where state-of-the-art development of embedded software was being done on Windows 3. Why? Because the people who developed the tools that all the engineers knew had left and they didn't know what to do next. So in the embedded space, we still have a lot of fragmentation. I'm going to talk a little bit about this later, but there is more to do. And some of the high priorities are to get some of the modern tools, Yocto, Open Embedded, Zephyr, and other RTOSs, building on ARM with ARM tools so that you do have a choice. So this is an activity that you'll hear more about this week. Okay, let's talk a little bit about machine intelligence, machine learning, deep learning. Even in the space of just 6 months, this has moved from a lot of companies working on this behind closed doors to a large number of companies working on IP for machine intelligence across the entire spectrum, from microcontrollers all the way up to big iron servers and HPC. It is becoming important and applicable to every area of technology and business. So what's actually happening? What's actually happening is this is no longer something that's done on big iron in the cloud. This is no longer something that needs 50,000 servers working on up in the cloud. We're moving more and more compute to the edge. We're moving it away from the cloud and closer to devices. And as we move to a world of 5G, this is becoming more important because the amount of data we are creating is just exploding, and there just isn't the bandwidth, and it doesn't make economical power sense to send all that data up to the cloud and then bring it back. There's a lot of cases where we want to move that processing closer to the sensors that are creating the data and send metadata to the cloud. So what we're seeing is kind of as you would expect. There's over 2 orders of magnitude power and performance improvement for certain algorithms if you have dedicated hardware. So historically GPUs, nowadays augmented reality, and of course machine learning algorithms. And there's a lot of people creating innovative machine learning algorithms. We're just at the beginning of this new world. And there are people using existing DSPs, specially designed DSPs, FPGAs, GPUs, neural processing units, full custom hardware designs, and neural networks, and so on, to try and tackle this problem. So, a lot of fragmentation. But there's this trend towards having either one or multiple dedicated hardware engines on SoCs for specific tasks. And the challenge is, how do we cope with this explosion of IP, this explosion of people building hardware into chips, and efficiently allocate these many different IP resources, hardware resources, to workloads? TensorFlow only supports a limited number of pieces of hardware. But what if we could use any hardware and there was a framework to enable the translation of TensorFlow requirements and graphs to the hardware efficiently and effectively, that each IP vendor only had to write once and it would work with every framework. So this is an area that Linaro has identified as needing industry cooperation. And the Machine Intelligence Initiative that was started by the Linaro core members is aiming to optimize AI and machine learning, deep learning performance, and to create modular integration of open source or proprietary vendor-specific runtimes for vendor-specific hardware. And so this is going to need collaborative definition of a common framework with inference APIs, and it's targeted not only at Cortex-A, but also at Cortex-M. This also applies all the way down to sensors. And the current candidate that is being looked at by this team, that consists of ARM, Qualcomm, and others, is using ONNX and creating a plug-in architecture for ONNX that will enable you to describe your hardware IP in a plug-in framework. So I really hope that companies will get involved in this. There's a lot of discussion on it this week. This is not a low-cost exercise. We need to have some very bright people working on this project. So we are asking you to fund it, because otherwise we can't do it. Okay, let's move on to automotive. There's a lot going on in automotive. We're all waiting for this to be our car. So where are we? We're getting more and more sophisticated systems into production cars. Somebody said that they estimate that in a modern luxury car, there's probably 100 million lines of software code. In a fully automated car, there's going to be over 1 billion lines. And I don't think they're going to be very easy to get through some of the safety certification standards. So there's a lot of work going on now in today's cars on technologies that are being widely used across most of our members, because ARM processors, with their low power characteristics and their safety characteristics, are very applicable for this kind of market. And that includes ADAS solutions today, which are evolving, safety isolation, so how do you isolate the safety system that has been approved from the compute? Obviously IVI, ECU updates. Cars are getting very complicated. They have lots of computers in them at the moment. And so how do you actually update that software? How do you update the software in a car, know where that software has come from, and then be able to transfer it to a new owner without any problems? AutoSAR is an industry organization that's trying to specify how to deal with some of these issues. And vehicle-to-vehicle and vehicle-to-infrastructure applications are starting to come from many of you in the room here today. And of course, vision. Today, we're doing a lot of vision already. We've got rear-facing cameras. We've got cameras to detect cars coming along the side, give us warning about objects in front of us. And this is just the start of the move towards fully autonomous driving. So Linaro is where we should collaborate on these activities. And I encourage every member and companies who are not members to come together in Linaro and work on open source software collaboration for your automotive software. Traditionally, a lot of automotive software has not been open source, but it's now getting a big market, and it's too important to go and fragment it. So this work is being done in the Core Systems Technologies group, and we need the members to get together and identify what are the key areas to work in this space. So there will be discussions on this in the TSC this week. In addition, as I said last time, we want to start an autonomous vehicles initiative. I talked a little bit about this at the Automotive Linux conference recently in Tokyo, because we need to have open source solutions for the future of autonomous driving. We, since the last meeting, have come to an agreement which we've announced with Tier 4. Tier 4 creates software called Autowear, which provides localization, route planning and mapping, object detection and driving control. But it needs a lot of work from the community to help make it a production quality kind of product. And there are a lot of companies who have taken it or using it to create proprietary IP. That's great, but we need to feed back the results of that and make the project better. There's also Baidu's Apollo project, which has similar aims. I'm going to show you a brief video from LG's team in the Valley, and they have built a simulator for basically running simulations in Autowear. So you're going to see this on some models they've created, which is essentially showing a simulation of Autowear actually driving in a car in San Francisco. So it's taking a simulation of the LiDAR data, and then using the map that's been created and the lanes and knowing where they are to be able to navigate through. And here, what you see in the bottom left-hand corner is Autowear identifying objects as the car is driving along that will be used to essentially make sure that even though you know you're supposed to go in a straight line, there's objects in front of you. So this work has been done by LGE Labs in in the Bay Area. They would like to get us involved in this. We would like them to come and get involved in what we're doing. This is an open source project, and we intend to actually link it in. What we'd like to do is link it into the work that we're doing with Tier 4 on Autowear. So what we're doing at the moment is really finding out what the scope of the problem is. We know Autowear and some of these advanced technologies can run on high-end $15,000 NVIDIA equipment. What we want to do is enable it on more ARM SoCs. So one of the things we're doing is a proof of concept. We don't have much resources on this. We'd welcome any additional resources from members. But we're going to basically use Autowear and ROS and other technologies that our members are interested in and put together a proof of concept that we hope to demonstrate to you at the next Connect, where we hope to actually be demonstrating the results of this, the goal of which is to create a software platform that we can use to do further work on open source software for autonomous driving. Okay, let's switch tacks a little bit onto 96 boards. The 96 boards ecosystem is growing very rapidly. Unfortunately, Yang Zhang, for visa reasons, back to geopolitics, wasn't able to travel here this week. But he, as the director of 96 boards, has been working very hard to get more and more of the ecosystem involved. And all of these companies are either on the 96 boards steering committee or they're manufacturing 96 boards products, and they have a manufacturing partnership with us. Some of the more recent boards that you may not have seen are actually in all areas of 96 boards. So IoT in particular, Zigbee and BLE boards using TI chips. There are companies building LoRaWAN boards using ST micros. And then UC Robotics has just introduced 802.11ac 2x2 Wi-Fi plus BLE5. What's really interesting about this is it's a 28 nanometer chip and has a 416 megahertz M4 in it. So you can do some pretty powerful stuff in this, and it can support a PHY of over 700 megabits. And NB-IoT, path towards 5G, is also available. BPI are building a product that supports, that uses the ST-MCU as the applications processor. So more and more of the sort of standard IoT boards are being built on this footprint. They all have the same expansion capability, and you can use them for developing software and products. CE boards from Geniatech, they've taken over a version of the Dragon board. Rockchip, I talked about last time. These are A72 processors for $69. Runs OpenCL, OpenGL, and they also have an AI chip in there. High Chips and Allwinner are doing a far-field development kit for building home speakers and things, if you want to experiment with that. And in the enterprise space, global scale, using an M-Star chip, have a board that can do 4K video, 4K TV, set-top box applications for development of that. The point is that all of these products are based on new technology. They're helping us get access to new technology more easily, and that helps us build better software sooner. Which brings me to IoT. And I think of IoT as basically everything now, everything that's not a server. The reason is because every time we connect something to the internet, it's essentially an IoT device. Doesn't matter whether it's a wireless device, doesn't matter whether it's a car, we're connecting to the internet. We haven't done this before. Historically, building embedded products, we could test that embedded product, we could certify it, we could build it, and as long as we didn't change anything around it, unless there was a hardware failure, it was going to keep doing what it was doing. That isn't the case anymore. So as we move towards the trillion devices connected to the internet, we are going to be creating billions of edge interfaces. For those of you who thought edge is not coming for a while, too late. We need to think about edge computing in everything we do from an open source perspective. So in Linaro, we're working across Linaro on IoT devices. In core engineering, we're building tools, we're working on security, we're working on infrastructure. In light, we're working on software for very small devices with microcontrollers. In ledge, we're looking at software for the edge. So how do you deal with gateways? How do you deal with multi-layer gateways? How do you deal with industrial IoT? And in LDCG, we're dealing actually with software for the data center and cloud that's going to be used in all of this technology to process and interact across the planet. And these devices are not mobile phones, right? They're not being replaced every year. This is infrastructure. This is going into cities, it's going into homes, it's going into places where it's just going to be. It's not going to be a shiny toy that you replace a year later. This is something that's going to be running software for a long time. Talking about microcontrollers, which we were earlier. I recently saw, when I first started in this business, microcontrollers were very simple. Recently saw a microcontroller with a 4,000-page technical reference manual. These are not simple devices. There are going to be bugs. Spectre and Meltdown was a sign of things to come. We didn't even know they existed, but they were there in an awful lot of the hardware that we have. Luckily, they're very difficult to exploit, but I guarantee you we're going to find a problem in a mass-deployed device at some point in the near future. So we have to change the way we're doing things. And LTS, I talked a little bit about this last time, I'm going to talk about it again, has been a really useful thing. It has enabled us to isolate the kernel from the applications and to have a kernel that is stable and supported for a long period of time. But what about the firmware? What are we doing about that if that goes wrong? And even if there's an LTS problem, what we found with Spectre and Meltdown is if you have got a kernel that's 3 or 4 years old, it's actually really hard to get those patches back-ported to 3-year-old, 4-year-old software, because the mechanisms for fixing it, which have been done in the latest kernel, they don't work in that old kernel. We have to do it a different way. And actually, how many of us are really interested in fixing up 4 or 5-year-old code? Well, luckily some people, but this isn't going to scale. And what's happening today is, even if you build the LTS kernel and stabilize it, every vendor is putting their own BSP on top. Are they giving you the same guarantee of support as you're getting from the open source Linux community? No. And on top of that, developer board makers put their own kernel pieces in that some product vendors end up using. And then the product vendors make their changes to the kernel. So every kernel is different. And all the testing that everybody does on their products, it doesn't get back into the LTS kernel. They just patch up what they're doing, and they've got their product, and it's passed their tests. And they go to market because that's the quick thing to do because they need revenue. So this isn't scalable across thousands of companies building IoT products. We've got fragmentation. We've got a basic lack of security. We've got a very high cost of maintenance all the way across the ecosystem. And is it any wonder that we're filling up our houses with devices that we need a kind of IT guy to help us manage all of these devices in our house? It's because we're not working in the same way with the same software. It's a problem. And I actually showed this slide, but I didn't notice something last time. This is the result. You have a 2017 model, mass market car. This photo was taken in that car. It's an IVI system with Bluetooth, and it uses kernel version 3.1.10, which was released in January 2012. The scary thing is that this build, they obviously know about LTS kernels. This is probably built by a tier 1 vendor, is June the 9th, 2015, in a 2017 production model car. How many security bugs since this kernel was built have been found? And this is connected to the internet. And it's going to be on the road for another 10 years. And I guarantee you that they're not going to update this kernel every time you take the car to the dealer. This is the scale of the problem. This is in a car, but this applies to everything. So fragmentation of platform software is dramatically reducing security. It's reducing our ability to react to flaws, and it's dramatically increasing lifetime costs. At least we're starting to learn that OTA updates are not optional. You have to be able to update the software in any product that you develop. This should not be a value-added feature. This is fundamental, or we're going to hit big, big problems. But think of what it means if you can update all the software on a product. You don't necessarily want to do it, but if you can, it gives you some big opportunities. Now, Linaro's mission is to collaborate in the ecosystem to accelerate the deployment of ARM-based systems. And yet sometimes it feels that we're all going in our own direction and we're actually achieving the opposite. With good continuous integration, continuous testing of small changes, so every change gets tested and you can isolate when you are introducing a regression, if you've got a big enough test set, then the latest software is the most stable, the most secure, and the most functional. When you buy a certain phone from a certain manufacturer, 2 years later, it's running 2 years later software. It's a heck of a lot more stable. It's more secure, and it's actually got a whole bunch of new functionality. So with OTA updates, if you buy into the fact that we've got to be able to update software in our products, then rather than long-term supported kernels, what if we could align on a single upstream aligned code base and keep it always updated and always improving? That is, after all, what we do. We work in upstream. We fix things. We create new technology, and we apply security patches first in upstream technology. So why aren't we delivering it to our customers? Why won't they take it? How do we show them that this is actually a better way? Because if we could do it, then you're scaling a single code base across multiple products. And every use case, every company that builds a product is making the core platform better. Yes, they're putting their own IP on. That's great. And they'll maintain their own IP, and that will be their secret sauce and how they create value and grow. But if the platform is Linux or Zephyr or FreeRTOS or Embed, and it's open, then we can scale out. We can actually benefit from everybody's testing, and the product will get better and better and better. So I challenge Linaro to try and help solve this problem. I think a lot of you know that a small group in Linaro went about a year ago and spun off a company which was called Open Source Foundries. And it's now called Foundries.io. And Alan Bennett, who many of you know, was the technical leader of that team for many years, and he worked in Linaro for many years. I think most of you know that he unexpectedly passed away about a month ago. But he was a very special person to a lot of people in this room and to everybody who knew him. He touched the lives of people he met. He was funny. He was inspirational. and he was an amazing technical leader who had a passion about everything he did. And so I thought it would be appropriate, since you haven't seen what he and his team have been doing over the last year, that in memory of Alan, we showed you some of the progress that the team and the company has made. So what Foundries.io is doing is it's trying to fulfill the promise of IoT from a commercial point of view by delivering continuously updated software platforms to make a secure, connected world. And it's basing off Linaro's work. We're using trusted firmware. We're using Zephyr. We're using Open Embedded in Yocto. We're using Docker. So all of these technologies are being used to actually create this continuously updated platform. And the company's products are micro platforms. They're the minimal secure software base you need to build an IoT or an edge-connected device. Now, you're not going to have one binary for every IoT device, right? The binary would be this big, and the devices are this big. So it's a single source code base. It builds in OTA updates and security to both RTOS and Linux implementations, and it's continuously integrated, tested, and updated. I'm going to ask Tyler Baker, who's Foundries.io CTO, to come up and do a quick demonstration.
All right. Logged in here. Perfect. Okay. It's great to be back at Connect, finally. See a lot of familiar faces, so thanks for having me. Today, as George mentioned, I want to show you what we've been working on. So I've got a few exciting demos for you. Hopefully you'll find them as exciting as I do. So I want to talk about what makes an OTA update secure. So really it's the proper use of encryption, digital signatures, and one-way hash functions, along with timestamps and a good key rotation scheme. So what's really neat about the implementation that we put together is that your root key or any keys in your tree can be compromised, and you still have a mitigation to regain control of the targets in the field. So it's a very robust over-the-air update solution that we've adopted. So we use the update framework /Uptane, which is a specification, and it's open source, to implement the secure over-the-air updates. We use OS tree on the Linux micro platform to deliver a Delta-based image layer, and then we use the hashing and the digital signatures and the encryption to ensure immutability, privacy, and verification of the images. So then, not only do we just update the user space, we update the kernel and the boot firmware as well, so the entire system can be updated with what we built. So the hardware I have in front of me here, this is a Raspberry Pi 3 with a 7-inch LCD IPS display, and then I have an Intel x86 Celeron, 8 gigs of RAM, 500 gig solid-state drive connected to a 24-inch monitor. Now they both have these speakers that you see in front of them. They're microphone and speakers. I'll get to that in a second, but essentially they have similar hardware, but what makes them special is they're running the exact same software build.
You've forgotten my piece of hardware.
Oh, yes.
Microphone. You've forgotten my piece of hardware.
Yeah, George built this one. So
I built this one. This is running Zephyr and has a Cortex-M micro and a Bluetooth.
Yeah. So that one's
No
battery
wires.
powered, and this one here is the exact same hardware, but it's been 3D printed and has an LED ring, so it looks more like a traditional light bulb. Of course, it runs off line voltage, and yours is running off 5 volts, so I'm going to really roll the dice with this one. Okay, so let's do an over-the-air update to start things off. So this is our dashboard, our demo server, and you can see the devices that I have managed here. And if we take a look at the NUC O1, which is the x86 box here to my left. Oh, has the internet gone out? There it goes. Okay, great. So you can see hardware details, IP addresses, all that stuff. But what you do if you scroll down here is you see that it's not running the latest software. So we're on build 26. We should probably move it to 27. So let's go ahead and click apply here. And it says the device is updating. So we've started the OTA update process on the NUC. Let's go to the Raspberry Pi that I have here. So it's also on 26. And if we look here, you can see the hash. And if I go, you can see the hash that we're on right here currently. This is a B7D80 and B7D80. So if we apply the update, we want to move to A64A. And so we've started that process. So both devices are updating right now. And while they're doing that, what I want to show you is a quick couple of demos. So typically, embedded use cases, there's a digital signage use case that's pretty common. So I want to show you that real quick. So I'm going to use Docker Compose. Let's just do this on the Raspberry Pi first. If I can type this morning, I swear I can do it. So what we're going to see here is we're going to run X in a container. That's going to drive these displays from within a Docker container, and it's also going to produce a lockdown Chromium mode. So if you want to display a website or a schedule at a conference, this would be a use case that you'd use. So the important thing to realize here is the same container source is used across platforms, and it's seamless. It's the same command. To a user running on x86 or running on ARM, there is no difference. I can't see if they've come up. OK, great, they've come up. So now I want to up the ante a little bit here and make this demo more complicated. So I'm going to see if our Google Assistant demo is going to work. So what we have is the Google Assistant running also alongside the X container, talking to LaShawn, which is using LWM2M and the Zephyr micro platform on these devices. And the idea is to control it with my voice. So let's see. Hey, Google, what time is it?
9:46.
Hey, Google, turn it on.
Okay.
Uh-oh. Yeah, let's see what's going on here. Hold on a second. Of course, this isn't a demo. Yeah, we've lost everything. No, there it is. Hey, Google, turn it on.
Okay.
Yeah, I'm not sure what's going on here. Let's move on. Anyways, okay, so we've got some problems here. But if I mute this speaker and I unmute this one, I can do the same thing on x86. So, hey, Google, what's the weather like in Vancouver, BC?
Right now in Vancouver, it's 56 and cloudy. Today, it'll be partly cloudy with a forecasted high of 59 and a low of 49.
Well, that's not a great forecast, so I was hoping for better weather, but we're just going to have to deal. So let's just check on our updates now and see if they've finished. Okay, so the Raspberry Pi has told us that it's updated, and the NUC's on 27, so let's just check OS tree. Okay, so now the image that we want to have, we're still running the old image, 16188. If we look back here at the NUC, we can see the hash. We were on 16188, but now we have a pending update that we need to apply, which is 35857, which is 27. So let's go ahead and reboot both these devices now.
Let's hope it was a bug in the software.
Yeah, let's hope so.
The update might fix it.
So yeah, kind of what you've seen here is Docker containers that run the same source across architecture, controlling hardware, driving displays, driving microphones and speakers. I think what's really neat about this demo, should it work, hopefully when it reboots it works fine, is that it's doing a lot. There's a lot of technology going on here. So we've got an update happening in the background. We're driving a display. We're taking audio samples in real time, doing the language processing on the device itself, sending it to the Google Cloud, receiving an event, acting on the event, and actually changing light states, ideally, when everything works. So let's just take a look here. Okay. Looks like they're starting to come back up. I can't see those screens. Okay, so we've got the x86 box up, and let's just do this. These guys. And let me see when LaShawn's going to come back up. Okay, so what you've kind of seen here in the x86 box, I can't see. Oh, there it goes. Okay, so we've done an over-the-air update securely, and the applications we were running in our Docker containers still function. So we were able to basically isolate the user application from the base operating system, which is kind of a new concept in embedded. Usually you bundle everything together as one monolithic image and you roll out updates to that. So I think this enables users of this system to be able to deploy software kind of independently of the OS, and so we can keep things up to date a little bit easier. Okay, so the devices have connected back to the Raspberry Pi. As you can see here, let's just try this demo one more time. Okay, Google, turn it off.
You got it.
Yay. We're not done. We're gonna up the ante here a little bit.
I told you there was a bug in the previous version.
Maybe it works now. Hey, Google, turn it on.
Sure.
Hey, Google, make it blue.
Okay.
So it parsed my voice on a Raspberry Pi, knew the color, sent it back to Google servers. I received an RGB code, and then updated the lights in a standard fashion. So let's do one more demo. Hey, Google, start it.
I found a couple places. The first one is Blue Star Motors at 1365 Main Street, North Vancouver. The second one is Blue Sky Japanese Bistro at 1815 First Avenue West, Vancouver.
You guys are gonna have to try those out.
We need better AI.
Hey, Google, start it.
Sure.
Okay, so what you're seeing here is an HSV color wheel demo. So in real time, in 2 different threads on the Raspberry Pi, we're controlling the lights over LWM to M. So there's a lot of stuff going on here, and I can kind of explain it a little bit. So what we have is DTLS securing the communication between the lights, Bluetooth low energy, and then 6 low pan running underneath it. And we're signaling this via UDP, so that the latency is pretty quick here. Now let's go back and just quickly check that our updates worked. So if I go, okay, so 35857 is active. We've updated our operating system. Let's just check it over here. Yeah, so we've updated. So we've updated our base operating systems. Our containers have maintained the same functionality, and we've done this all securely. So just to quickly summarize what we just saw, there was a whole lot of stuff going on here. Linux microplatform running across architecture. You've got the Google embedded assistant actually running on the hardware, not running in the cloud, on Raspberry Pi, ARM64 hardware, and x86 hardware. Then you've seen a secure over-the-air update to both of these devices in the field, and that the applications and containers and the base OS can be updated separately. And really to hit the point again, the same software running on ARM in containers and the base OS as it is on x86. Thank you for your time.
Thanks very much, Tyler. Let me just see if it understands my accent. Should it work? Okay, Google, turn it off. Okay, Google, turn it on. Okay, Google, set brightness to 10%. Okay, Google, turn it off. Okay, Google, tell me a joke. Okay, Google, tell me a joke. Which one? Okay, Google, tell me a joke. Doesn't like my accent. It obviously doesn't like my accent. All right. So what we've actually done here is created an end-to-end platform. This is tested end-to-end all of the time. Every single build, every single change, whether it's in Linux, the RTOS, the firmware, the cloud, is being tested on every check-in. And if you think about the technology that is needed to do this end-to-end, you have to do that. You have to test end-to-end all the time. So this is foundational software. We are not in the cloud and device management business. We are agnostic as to what cloud you use, what you do with your data, whether you use Azure or Alibaba or Pelion or any cloud device management system. What this is doing is simply giving product developers the ability to have a secure, updatable platform for building software for their products. You can try this out today on a Raspberry Pi, a Dragon board, a BeagleBone Black, an Intel box, and some others. And you get for a subscription, you can have a personal or evaluation license that gets you every single update. So you're getting continuous releases. Now, as a product vendor, you obviously don't necessarily want to update your field products apart from anything else, it's expensive to do an update. But you want to be able to, because there is a problem, you need to be able to react to it and deploy it immediately. And of course, if you have this capability, you can actually deliver new functionality. Finally, there's no lock-in. This is open source technology we're building on top of. So at any time you can stop subscribing, you can keep all of the software. It's all there, it's all in source code, and you've built binaries, and you're doing updates. You have everything you need, but you will then need to provide maintenance moving forward. Okay, so that's what Foundries has been doing, and we're very proud of what we've achieved so far. Watch this space. We're going to continue to work very closely with Linaro and depend on Linaro moving forward. So on the Linaro side, today and tomorrow and for the rest of this week, we have the normal sessions, and Joe will talk more about that every day. But I did want to highlight a couple of particular things. On Wednesday, as Joe said, we have the AI and Neural Networks on ARM Summit. We have some very interesting keynotes that day from Jem Davis and some speakers from Amazon and Google, who I think will be very helpful in giving us additional information on what we need to do in terms of AI and machine intelligence. On Thursday, I'm very pleased to say that Toshiyuki Shimizu from Fujitsu will be here, and he's going to talk about the chip that's been developed for the post-K computer. And on Friday, Shinpei Kato of Tier 4 will be here, and he will be talking about Autowear. Finally, I'd like to actually make an announcement about Fujitsu's silicon. The A64FX is the first processor in the world to use the ARMv8A SVE architecture. And it was designed to be part of the post-K supercomputer project in Japan. Today, I actually have here, I think it's definitely got something to do with marketing because it doesn't have confidential and lots of numbers and things written on the top of the chip. But this is a real chip off the fab. This is a first A64FX chip. And this is, as far as I know, the first time in the world this device has been shown publicly. So this is heralding a new era of ARM computing. This is the most powerful ARM processor that has yet been built in the world, and I'm holding one. So I'm really looking forward to hearing from Fujitsu on Thursday what the next steps are, but the silicon is now real. And the goal of getting this silicon into the market sooner than the post-K is obviously to seed the post-K supercomputer ecosystem and to accelerate our ability as developers to accelerate the deployment of ARM SVE technology into our code bases and our tools. So come back on Thursday and listen more, and maybe they'll have put it in something. We'll have to wait and see. But I'm really pleased that milestone's been achieved, and congratulations to Fujitsu. So, as we said, just to recap, open source ignores boundaries and sanctions. Mostly, there are a few security issues that we have to deal with. Native ARM deployment is getting easier and faster, and ARM is now in the cloud. AI hardware IP is everywhere. Let's make it easier to use. And autonomous cars are coming with open source compute, but there's a lot of automotive software to do in the meantime. The 96 boards ecosystem is growing rapidly. That gives us new hardware to work with upstream. And LTS is still very useful in the mobile world, but infrastructure and embedded products are different. We're connecting them all to each other now. LTS may have had its day. Upstream is definitely the way. And finally, also on the way is post-K. Thank you for your time.